If you're training a deep research agent with reinforcement learning, you're likely using an LLM as a citation verifier. But do you actually need a frontier model? Recent work on RLVR, reinforcement learning with verifiable rewards, treats rubric-based LLM judges as your reward model. The catch is citation quality isn't a single metric. It decomposes into source relevance and factual support, and the judge's scoring behavior directly dictates what your policy actually optimizes. To test this, researchers built the Deep-Research Citation Benchmark. It's an adversarial dataset of 624 attribution citation pairs, stress-tested with 19 distinct factual and topical editing strategies. They evaluated 8 off-the-shelf judges across OpenAI, Anthropic, and Google. They tracked pass-class F1 and Cohen's kappa, but the real focus was on pass rate drift, false positive rate, and false negative rate. Here's the critical insight: scalar F1 is dangerously misleading. Judges with nearly identical F1 scores exhibited drastically different directional biases. A high false negative rate creates signal sparsity, training your agent to overhedge or undercite. A high false positive rate directly enables reward hacking, where the model learns to game the judge's permissiveness instead of producing faithful citations. Cost completely failed to predict performance. GPT-5 Mini and Gemini Flash Lite hit competitive source relevance F1 scores, while factual support confidence intervals overlapped across every single model. The takeaway: you don't need the most expensive model to verify citations, but you absolutely must calibrate directional bias before plugging a rubric into an RL loop. The full benchmark pipeline, prompt architectures, and adversarial strategy breakdown are in the linked paper. Essential reading for anyone building grounded, RL-trained agents.